Okay, thanks for confirming. So, good afternoon, everybody. Uh, Brief introduction of myself has been already given by Payal. Just a small correction. My total experience now stands at 24 years plus, uh, and that will be the first thing on the presentation also. So, I'll just move to the slide for the introduction. I started as a VB 5.2 developer, moved on to VB6, and then started working on .NET framework since the very first beta release of .NET, which officially was put forward by Microsoft in the market. And since then, have worked with all the releases of .NET framework till date. The latest being .NET 4.8 when it comes to the Windows only framework. And around 2013-14, they came up with the first beta release of their cross-platform version of .NET as well. And I have worked with all the releases of .NET Core platform as well, which was the name given by them officially to the cross-platform version. When I say I have worked with all these releases, so that actually means I've delivered some projects on them. I have delivered some trainings on them. I have delivered some consulting assignments also on them. It's not something like that, only training or only development work or only consulting work that I've done. It's a mix of all. Beside the development platforms, my other skill set basically focus on the web development. So that all started with ASP.NET to be precise. And then I started working with ASP.NET MVC in year 2010 when it was released, which was then followed up with multiple client-side libraries and frameworks that have been put into the market by different communities and different organizations. So it all started with jQuery, in fact, which followed up with the Knockout.js, Backbone.js, and then I started working on Angular, not Angular.js precisely. Angular 2 onwards, I've worked with Angular, and then I upgraded myself on React.js as well, and currently upgrading on Vue.js. That's in the web development arena. I also started working with service-oriented architecture with Microsoft coming up with WCF, Windows Communication Foundation, one of their premier framework, which was added to the existing .NET 2.0 stack along with .NET 3 release. With that, I actually got my hands dirty on different standards of the service-oriented architecture, which included the web standards as well, and work with pretty advanced WCF scenarios, which eventually ended up with the RESTful service development with WCF. And then, as Microsoft already introduced, the REST API development pretty much supported with ASP.NET MVC framework, where they got a sub framework into it called as Web APIs. So moved on to Web APIs. And since then, working with the RESTful APIs using the Web API framework a lot. Beside that, I've also worked with the RESTful APIs being developed using Node.js and Express. So that's in the web development arena. And that's where actually the seeds were sown for the service-oriented architecture, followed with the microservices architecture and so on. And hence, I am here for this particular presentation on microservices architecture with .NET. So microservices is one thing, .NET is just one way using which, one platform using which you can develop your microservices based applications. And the important part over there is you have to pick choose one or the other platform, one or the other technology, so that you can do the implementation the way you want. So I pick choose the .NET platform. Coming from the .NET background, that was the obvious choice. And this presentation is all about the same. Beside this, I work extensively with Microsoft Cloud Services also, officially, which are named as Microsoft Azure. And I'm working with Microsoft Cloud Services, Microsoft Azure precisely, since it was released for the first public preview by Microsoft. So right from year 2010, early 2010, I'm working with it and have seen many updates to it. And I have been a witness to how they have made the life much more easier for the cloud developers over all these years. So let's get started. What all things we are going to talk about in this presentation. It all starts with the introduction to microservices architecture, what it is all about, uh, why the buzz, why the hype, and then some history of it, how basically microservices architecture became the need of the hour these days. So it all started with the older architectures, which we used to call as monolith architectures. So what monolith is, what were the pros and cons of monolith architecture. Then coming back to precisely the microservices definition, followed by the architecture itself. Then some add-on features that probably we need to work with while developing and deploying the microservices based applications. So that's where we will be talking about containerization systems. Precisely, for example, we'll be making use of Docker. And I've mentioned hands-on, but as this session is a 1 hour 30-minute session only, practically hands-on will not be possible. It is more of a curtain raiser towards microservices architecture with .NET. So if you have the need for the full-fledged program on this, we keep on delivering such kind of programs for multiple corporates as a corporate training requirement. It could be project-based, it could be a calendar program. Apart from that, we keep on doing the workshops also, wherein people from different organizations come in and attend the session. So let's first of all talk about the traditional monolithic applications and exactly what is the architecture of those monolith applications. Once we understand this, then we will be in a better position to understand the pros and cons of monolith architecture. Pretty traditional. Probably this is the architecture we have been following since last 30, 40, or maybe more number of years. Ideally, I would put the timeline in a way when the typical line of business applications or application development actually started. Since then, we are following this architecture. So let's put it somewhere around early 90s or mid 90s, where the line of business application development started, where we had the desktop applications to start with, followed up with the web applications in the first decade of 21st century, which we are still following, right? So the most popular architectural design that we follow while developing any kind of these applications, even if we talk about the mobile applications also, the architecture that we follow is N-tier architecture. Am I right? Just raise hands, those who agree with me. Now, when I say N-tier, it could be 2-tier, 3-tier, or maybe more number of tiers coming into it. That's why I use the term N-tier. Yes or no? Just two responses so far. What about others? I'll wait for 30 seconds more. Yeah, I believe that's the case. N-tier architecture is the most popular one. Even if we talk about the MVC architecture is just a different perspective towards N-tier architecture only. Am I right? To make your components more reusable, more loosely coupled, and then more testable. Yes. Now, typically, if we talk about three-tier architecture, which is the easiest one for us to understand, what are the three tiers into it? You have a data access layer, then you have business tier, then you have presentation tier, correct? All are kind of role based, or probably we can say some responsibility is there that has to be played by all of the tiers. Data access tier has got the responsibility to talk to database for data retrieval, for data updations, insertion, updations, deletions, whatever it is, right? That is all taken care of by your data access tier. Whatever logic that goes into data access tier is not business logic, it is all database logic or data specific logic. Am I right? That's what the architecture says. Then when it comes to the business tier, this is where we have all the logic which takes care of all of your business related decisions, what we call as business or domain specific logic, right? Decisions, calculations, all goes in business tier. Next is presentation tier, which has got the responsibility of presenting the user interface to the user. Now, what kind of user interface it is, it doesn't matter. It could be character based, which we used to have in early 90s. The command line based interfaces used to be there, right? Which got replaced with the desktop applications, Windows or Mac or Linux, GUI based applications came in. Then they further got replaced with web applications. And these days we work a lot with mobile apps, correct? All have user interfaces. If this is user interface, any of these kind of user interface is not there in place, it will be entirely impossible for the end user to interact with the system, correct? If there is no interface, how they actually use the system? There has to be some mean. It is just like there is a mobile phone, smartphone, in which there is no app and there is no way you can download and install the app. That phone is of no use. It's just a box, dummy box, correct? You need user interface to interact with the system, where you can give input, where you can interact with the apps, where you can receive the feedback from the application. I mean, where you can see the data coming back from the application, some reports, right? All are integral part of your application, right? Without data access layer, your application has no mean. Without business tier, there is no domain angle to it. business specific angle to it. Without presentation, user cannot even interact. Correct? So all the three tiers are very, very important in any application. I hope everyone agrees on this. They are coupled with each other. Whether it is loosely coupled or tightly coupled, that depends what kind of design patterns you have followed, what kind of object-oriented principles you have followed, right? I'm not talking about that. Let's not get into that as well at this moment. Point is, we have three tiers which need to interact with each other, so there is some coupling. Now, usually if you see this approach, all of your business logic goes in one component. All of your data access logic goes in one component. All of your presentation goes in one component. And there is a single database for the entire application, even if it is a very, very complex enterprise application, right? That's what the second point on the slide is talking about. All the business units or logic are implemented under a single application, and a single database is used for data survey. Yes. Now, the image, if you see, this is just a modern version of the same architecture that we used to follow. If you're having service oriented architecture being followed, your business logic or your data access logic might lie in some API. Now here I can see there are two APIs, products API, orders API. Both are talking to the same database. This is your application, and user is communicating with those APIs. For user to communicate with those APIs, there could be an intermediate application that serves as presentation layer, right? But now the point is everything is just one application, one single application. This is why we call it as monolithic approach or monolithic architecture. What's my point? There are some advantages or pros of monolith architecture. You know, it's usually easy to get started, set up the application, develop something, and make it running. You write all the code at one place. Even if you use the tiered architecture, still the overall project will be the same, right? Just some object oriented features you might be using so that they look like different parts of the application, but eventually they end up in same application, right? Even if you say that, okay, I'm using component oriented architecture, components may be different, but then all components are integrated under one single application only. Yes. So setting up and getting them started, getting them up and running is relatively easy for the developer. Once the development machine gets configured, running the solution is as simple as pressing F5 in Visual Studio, right? And as I said, as everything is in same solution, the debugging also becomes easier, simpler. Deployments are also easy because you need to handle just one project that need to be deployed. Yeah, it may be the case that you need to have it scaled up for a huge number of user base. So in that case, the deployment, if it is a web application, probably needs to be deployed on multiple web servers with load balancer configured in between, right? But ultimately, the deployment package will be the one. There are not many multiple packages that you will be actually using. Yes, same process you have to follow across different servers, whatever you will be following on the first server. So there could be automation script also. And with modern DevOps features coming in, with CI/CD features being used, it becomes much more easy, much more automated. Correct? But then there are disadvantages that we need to understand so that we understand why there was a need for some other different approach. Precisely, microservices approach here. So, when the application development starts in monolithic manner, initially it looks pretty much easy. I have everything what I want. I'm just going and updating the code. But once you start adding new and new features, right? The change requests come, maybe some issue needs to be fixed, right? Some new features might be getting requested because usually these days we are following agile. So agile basically says that you have to be ready for all these situations, correct? Your application is not built from start to end at one go. There are some portions which are built, put to the user acceptance test, and released. Meanwhile, you keep on adding more new features to it. With every release, there will be more additions, more increments. So the features are added incrementally, right? Now, in this case, your code base starts growing exponentially, I would say. And there will be a point in time where everything will get so complex that even we will lose the track about what is implemented where. And that's where we understand the first disadvantage, code complexity, right? There are tools available probably to assist you in these cases, like ReSharper and all, right? But then there is a dependency. Also, it's not only about the code which grows. When code grows, side by side data is also growing because it's a business. Your user base is always going to increase. So your hardware requirements also start changing. I would say start growing. You need more powerful and more number of CPUs, more memory, more storage, which also increases the cost at the moment, right? So this all comes with the changing requirements. Now, this all requires the complete reanalysis of your project each and every time when we want to improvise the application. So that's what, like in DevOps terminology, will say that, okay, I am switching the branch, I am going for another version, right? Your existing setup probably will start failing at some time. It may not be enough for the new requirements, which are actually coming with the number of users being increased, your data being increased, volume of data being increased, and the complexity of code also being increased, right? So complete reanalysis required, which means there will be some downtimes also when you are doing analysis, when you are putting some load test on it, right? When you are deploying the new versions, basically with monoliths, the thing is the complete application need to be redeployed. Incremental releases is restricted. It's possible, but it's restricted. Even if you do incremental release, the application needs to be restarted from scratch. So what it means is there will be some downtimes also. The system will be unavailable when the deployment is going on for the new version. Even if the change is a very small change, like A plus B change to A minus B, still you have to go with the complete deployment to be reinitiated, right? Though the system might be behind a load balancer, deployments usually were planned when there is no or very less amount of load on the system. So if you look at the banks, you periodically we used to get in fact we are still getting messages from the banks that okay, on so and so date, uh, midnight to 2 a.m. or 3 a.m. the system will be unavailable because of maintenance. Most likely some patches are going on, some updates are going on, some redeployment is going on, right? Now there are some businesses which could be okay with it because their customer base might be in one specific region of the world. But the global businesses will never like this because their users most likely would be across the world. I mean, they would be present across the world, right? And in that case, there is no low load kind of scenario. You cannot plan it that way, correct? That, okay, midnight, 12 to 3 a.m., the system will be down. Now, probably in India, it will be a midnight, but in the other part of the world, it could be a typical midday. What if the users are actually using the system? There will be outage, right? And usually these outages cause lots of irritation at the end users level. I hope everyone agrees with that as well, right? So what comes to the rescue? Probably a different approach. One of the approach is microservices architecture. Now here we will try to understand what microservices architecture actually is. So here we're not completely changing the entire scenario. We'll still be using NTR architecture. If we are using MVC, we'll still be using MVC. What changes is each business unit or each component is developed in such a way that in itself it looks like a different independent application altogether. So for example, the order processing system, the architecture which was shown for monolith, we saw earlier on the slide, where we had products API and orders API talking to the same database. Why can't we do it in a way that products API talks to a database of its own, products database? Orders API talks to its own database called as orders database. And it's not only API talking to database, it could be a complete stack. Right from the database to the presentation, there is one single path, one independent path available for each of the component that we have, right? This way, each separate independent application will be lightweight, small enough, complexity will not be there. They will have their own responsibilities. So more loose coupling will be there, more testability will be there, which means more quality will be there, right? With their own responsibilities to be carried on, these services are something that we will call as microservices. So what we are doing is we are breaking down one big complex application into multiple smaller applications, right? In microservices, each service will have its own code, its own database, independent database. So the biggest advantage that immediately we get is if one of the service goes down for whatever reason, maybe for maintenance or maybe some malfunction, whatever is the reason, the other microservices will simply be untouched. They will keep on running because they will be running in their own address space or their own process. So they will be completely unaffected. So one service going down doesn't mean the entire application goes down, which was the case with monolith. Then another advantage is each microservice can be developed in any technology stack, any platform, can be hosted anywhere in the world on any type of host that we want, but still it will be part of one big goal, one big enterprise application only. So the technology dependency also is broken. This is very important because now these days we have the teams with diverse skill set. And if we are working on a big enterprise applications, the first challenge with monolith architecture will be to get each and every team trained on the same technology platform, which is time consuming, which is costly. And the end product will take time to get launched. So here basically we can say, okay, you are coming from some skill set, use that skill set and develop your microservice with whatever technology you're comfortable with. We are following REST patterns, so ultimately the services are going to be accessible everywhere in any application written in any technology, any platform. Make sense? Database is also independent. What does that mean is we have a choice. If we feel that, okay, for this microservice, I need SQL Server, I mean RDBMS. For other microservice, I feel that some NoSQL database like MongoDB is sufficient. I'll use that. One more advantage we get there is if one database for whatever reason is not available, the other database is still there. Means ultimately the other portions of my application will keep on working. Better loose coupling we'll see over here. Yes. Let's have a pictorial view of the same. We have products API, which is communicating with its own independent database called as manufacturer database. Order API communicating with its own independent database called as sale business database. In any case where product API needs some communication to be done with order API or vice versa, like where order API needs to communicate with products API, they won't communicate with each other directly by calling each other. If they call each other directly, means we are ultimately going back to the monolith architecture. Understand? So whatever communication is required, the service will just put it into some queue. Which queue? That is your choice. For example, here I have put RabbitMQ, but it could be Azure Service Bus. It could be Azure Storage Queue. It could be Microsoft Message Queue. It could be any queue, any enterprise queue that you feel can provide me a solution. Understood? So the other service will pick up the message from there and will process it further. Now, keeping track of so many microservices probably looks to be a challenge. I may have 1,000 APIs, 1,000 microservices. So how do I, as an end user, how do I keep track of 1,000 microservices address or endpoint? So for that, we probably can bring in the API gateways or API management tools, where at one specific address or one endpoint we send the request, and it is the gateway which locates the actual microservice to be used and distributes the call or forwards the call to the actual microservice that is required. Make sense? So for end user, it looks to be one application only. API gateway is just doing the integration of different independent microservices here for the end user. Any questions so far? You can use chat box. You can unmute yourself and ask. Yes, anybody?
Hi, Janmaja here. So,
Yeah, Janmaj.
the question I want to ask is, you told like for each microservice we'll be maintaining separate database, right?
Correct.
So, if there is a relationship between product and order database exist in the
Yes.
application,
Yes.
so how are we going to handle those scenario here?
See, in this case, we actually need to think in a denormalized database situation also. Uh, and logically, we need to maintain that relationship. We have to move away from what concepts we have in mind since so many years, right? So basically, what we will do is we will keep only the relevant information, I mean, the second copy of the relevant information with the other database also. Say, for example, order API. While ordering, I might require the product details, right? Now, when I talk about product details, I probably don't require all the product details. I may require product code and product name, right? More than that, maybe another field or so, not all the fields which I may have in a products table. So only that sub portion I can maintain as a second copy in my products API database, manufacturer database itself. So there will be some sort of replication required, which is where the message broker will come in. So whenever I add a new product, probably a message goes to the orders database also, or maybe to a queue also, that okay, there is a new product added. Here are the details. Now it is the duty of the orders application, orders microservice, to pull this information from the queue and update its own copy. Got my point, Janmejay?
Yeah, got it. So, will it not affect the performance of the application because we are doing multiple operation here?
See, directly there will be no impact as such because this all synchronization and replication will be happening in the backend, uh, not during the user's request itself. It is all offline, asynchronous communication which is going to take place. So it will not affect the performance at all. Right? Say, I'll give you one example. Let's say I give you a task. I have a project requirement. I give you the details. You are my single point of contact. Okay. Now, the requirement is so complex that you alone cannot do it. You have three or four of your friends, and you think that those three, four friends can help you out. Right? Now, behind scenes, you will be distributing the task to them. Is it going to affect the turnaround time for me? Because while sharing the details with me, you will consider all the scenarios, right? Most likely it is going to improve the overall performance only, right? Because the data will be locally available in my own database, and I don't need to scan the whole table. I just need to scan a portion. Even if I'm scanning the whole table here, the whole table itself is just a cut down version of the original table. Understood?
Yeah.
Makes sense? The
Yeah,
key
thanks.
over here is the async communication via the message brokers or queues. Queues are called as message brokers because they work in between, right? There is no direct communication. Yeah, I agree with you that the performance will be affected in a case where the synchronous communication is there. On the same call, I am probably communicating with the other API directly without any message broker in place. So that definitely in that case, the performance issues will uh, surface. Got it?
Yeah, yeah. Thank you.
Yeah. Any other question?
This is Anuj here.
Yeah, Anuj, go ahead.
Okay, so it means that we are maintaining the RDBMS kind of relationship using the API gateway.
Uh, no. Actually, the API gateway is just an integrator tool where it will make different APIs available via the single endpoint, right? And APIs are going to maintain their own relationships, again, not by directly talking to each other, rather by looking at the messages that are arriving into their queues. Understood? So
Oh, okay.
relationship is being maintained in a logical manner, not in the physical manner how it used to be there in a typical RDBMS situation. So in fact, because of this reason, many people go for the NoSQL databases rather than using the SQL typical RDBMS kind of databases here while working with microservices architecture. And that is the reason why you might have seen the rise of MongoDB and the similar databases these days. Yes, Anuj?
Yeah, so it is not RDBMS, it is like hierarchical management.
You can say that. You can
Yeah.
say that. So it's something in between. In fact, relationships also we do maintain, but that is very restricted. Okay. Yeah.
Hi, Saket.
Yes, Swapnil, go ahead.
Yeah. So my question is like when user request comes to this API gateway or API
Yes.
management tool, so
Yes.
on which parameter or rules it's identifying the appropriate microservice and passing it to the same?
See, basically here your request will be a RESTful request, right? So RESTful request can come up with header information also,
Yeah.
and then it may have some parameters into its route also,
Yeah.
right? Based on which you can actually do this routing, or you can have policies also created. Most of the APIM tools give you the policies feature, which basically scans your incoming messages and sees that, okay, who can serve it, and then
Yeah.
forwards it. Understood?
Yeah.
So if you have
Yeah.
worked with
Understood.
Azure APIM, probably you know that how to do it.
Yeah. Thanks. Yeah.
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 Okay. So let's go ahead. Some design principles have been put forward for microservices, just like for service oriented architecture, we had some principles. Here also we have some principles. The first being high cohesion and low coupling. Low coupling is more about loose coupling, which we probably already know that there is no direct dependency, right? What is high cohesion? Anybody? Okay, let me explain. So the overall idea behind this principle is that each service should do only one thing at a time and do it well up to the completion. This is where the term high cohesion or the service being highly cohesive comes in. There should be no dependency of one service on the other at all. If there is a requirement that, okay, now I have done something beyond this point, there is another service which should do something. I will not communicate with the service, but I will put a message into the queue or the message broker and I'll forget about it. I'll just assume that it will be completed. It is the duty of the next service basically to take it ahead from there. Understood?
So
Okay.
it is
So yeah,
so it is single responsibility.
correct.
Okay.
So in a way, you can relate it with the single responsibility also. Rather than single responsibility, it is more about doing just one thing, right? Okay, do your job, put the message in queue, and move ahead. Okay. Next is discrete boundaries. What is it? This is also one of the feature taken from the service oriented architecture only. Discrete boundaries talk about the microservices being small and independently deployable units of functionality, which makes them easier to be managed and scaled at any time. Scaled means you can scale them up, scale them down as per the need, as per the load, right? Now, let's talk about an example over here. Let's assume that you have built a web application that enables users to buy something online. Okay, typical shopping cart kind of thing, e-commerce kind of thing, you can assume. So in that case, you might have one of the microservice which is responsible for handling the user's login, and another one which handles the purchase and the billing process. So add to cart might be one microservice, billing might be another service once again. So each service will have its own areas of work. Okay. Next is actual single responsibility principle. What single responsibility principle says is there should be just one and only one reason for a object or a class to change at any time. What is the benefit of this principle? It actually reduces the complexity, improves flexibility, and maintenance becomes easy. It becomes easy to change any of the object implementation, I mean the class definition, without actually making them broken. And if there is no dependency, basically the other service will not be affected at all. Blindly, you can go ahead and make the change that, okay, this is the reason why this service should change because the behavior has to be changed. My calculation had discount component earlier, but now I don't want the discount component to be there at all. So even if discount percentage has been entered in the column, the discount should not be applied. So I want to change the logic, right? So this is only about one service being changed in this case. Understood? This way, there will be no conflicts with other microservices. Okay. Next is design for failure. What does that mean? Always be ready to accept the situation that your service may get failed. It's a logic running on some hardware, running on some machine. So you cannot say that it is always failure proof. Anything can happen. Any reason could be there because of which your service might go down, right? So your overall design of the service or the application should be like that. It's ready to handle the failures as well. Probably here you can use one of the design pattern called a circuit breaker, which is used to protect against the cascading failures in distributed systems or applications. What does that mean? If one service fails, because of which the other service also fails, which further makes another service fail. This is what the cascading effect is. So by default, your microservice design has to be such that there is no cascading failure effect at any point in time. When the service fails, handle it there and there itself. Probably if required, that service can be restarted also. And that's why the direct communication between the service should be avoided. The service either succeeds or fails. If failed, log. If not failed, put the message of completion in the queue. That okay, I've done my job, now it is your duty. In fact, that also need not be said. I have done my job, here is the message. What needs to be done? I don't care. My job is done. Understood? Failures can be hardware failures, failures can be connectivity failures, network connection failures, database connection failures, memory leaks. Could be anything, right? You have to be ready. So, two things: no direct dependencies. And the second thing is, whenever there is a failure, handle it. Graceful exit should be performed there. So, typically, in the coders language, we will say use exception handling wisely, right? Simple requirement. Next is business capability. What this principle says is you should always build your microservice around the business capability or precisely the business requirement. Each service should be responsible for a specific business capability. And when put together, all the services should be able to cover and provide all the necessary business capabilities or business requirements for your application. Right? So if one of the capability needs to be updated, you can easily update it. Next is decentralization. Decentralization means the distributed architecture being adopted more over here. Each service maintains its own copy of data. Even if there is a relation, that related data also is maintained as a separate copy. So there will be some sort of redundancy. But see, to make a typical microservice architecture based application work effectively, this is required. It looks like a burden up to certain extent, but we already discussed. This all is taken care of offline or in an asynchronous manner. So it doesn't impact the performance of your application at all. Right? Now, this way, the size of your database also will be small. Costing will be also manageable easily in that case. Put that deployment on cloud. Small database doesn't cost much. If one single database becomes too big, probably the cost also increases many folds. But in place of 100 GB of one single database, I have 101 GB databases that will be cheaper. It is just like your electricity bill. If you are using 100 units, there is a different calculation. But if you are using 10 devices with 10 units of consumption each month, and for which there are 10 different electricity meters, the bill will be different. With 10 different electricity meters, the cost will be lower because we have slabs there, right? So it just works that way. Right? And managing the backups, managing the disaster recovery for smaller databases also will be simpler. Also, it will be much more quicker. Backing up 2 terabytes or 5 petabytes of database will take a lot of time. Instead, if I'm backing up 5 GB of database, it will be easy and fast. Yes or no? Even if I have 500 such databases, I don't have any problem. Because on cloud, I can actually spawn different processes on different virtual machines. So they will all be running parallelly and independently. They will not have any impact on each other. So overall time consumed will be much more lesser. Yes. Next is process automation. What that is? This is where we need to bring in the DevOps culture. Which DevOps tool you use, that's up to you. Usually with .NET background, Microsoft background, people go for Azure DevOps, but then it's not restricted, right? You can go for any of the DevOps tools or DevOps platform. So here the automation is all about automating the processes for development, builds, and deployments. This ultimately has an impact on the reliability, cost reduction, plus the development cycle being sped up, right? So here, if one person is working on one microservice, basically only that service needs to be built and deployed. It will take less time. If you build the whole application, big enterprise application, the build itself takes several hours. That won't be the case with microservices, right? You will be always working with smaller targets. Next point is inter-service communication. So we already discussed this, in fact. The inter-service communication should never be direct. It has to be based on brokered architecture. So whenever there is a communication required, the service has to put a message in the queue. The other service picks it up from the queue and then fulfills it. Which queue platform you use, that is up to you. Understood? Next is automated monitoring. Now this is very important because we are working in a highly distributed nature of the service implementation. Microservices all are independent, all distributed, databases are distributed. So it's highly distributed nature, right? In this case, identifying errors using manual processes will be a very uphill task. That's where you need automation in terms of monitoring the health of the system. Most of the platforms now already have built-in health monitoring APIs. In .NET, combined with Azure Cloud, we have App Insights also, which can be one of the monitoring system that can be used. You just need to instrument your application correctly, right? And then the last point is command query responsibility segregation, or CQRS. So this is where what we need to understand is that the traffic to the services in microservices architecture, I mean, amount of traffic can be different at different times. There might be situations where you have huge traffic. There might be situations where you have no traffic at all. There might be situations where you have okay kind of traffic. Typical example is, Amazon, Flipkart, those special festival days are there where they launch the discount schemes for 2 days, 3 days, maybe a week or something. During festivals, usually they do it, right? Now, tremendous amount of orders they get on those days, because people also want to take advantage of the discounts, right? Apart from those days, I would not say that there is no traffic. There is traffic. People keep on doing online shopping, but compared to those specific festival days where offers are going on, the traffic probably is just 20, 25%, 30% at the most, right? So basically, the usage of the resources has to be planned based on what is the load. And this is where you need to plan for something called as auto scaling behavior of your service. And probably this is where the containerization can help you. If your service is deployed in a container, number of containers can be increased or decreased. I mean, instances can be increased or decreased as per the need, so that the overall cost of running the application also is in always optimized way. You don't pay too much than required. You don't pay too less and get less amount of resources so that users start getting the outages. You will always be in the optimized situation. That way you will be saving a lot of cost also. And the users will not be facing any outages as well. Make sense? There could be situations where reads are more, writes are less. So that also can be segregated. For read operations, maybe you can dedicate more instances, whereas for write operations, there can be less number of instances. Right? There could be a reader microservice, there could be a writer microservice, even if it is for the single object. That way, you will be able to independently scale your read and write operations. Yes or no? So here there is a comparison between standard service oriented architecture and microservices architecture. In a typical SOA model, that means service oriented architecture model, services or modules are shared and reused enterprise wide. Whereas a microservices architecture is built on individual service that functions independently. When you say services or modules are shared and reused enterprise wide, means there is one package within which all services are there. Now, I may not want all services to be usable and accessible by all. There are 100 services, out of which I want different packages for different users. By different packages means, okay, these 10 services are for these people, these 15 are for these people, these 20 are for these people. There could be some overlapping of services also, right? I want bouquets to be created, kind of a la carte basis. That is not something which is possible with SOA because it goes as bunch. Whereas in microservices architecture, each service being independent allows the bouquets to be created, and here the API management tools can help to create those bouquets, right? For every bouquet, I may have a different endpoint create. Next point, in a SOA model, developers reuse components as a means of enhancing scalability and efficiency. Whereas in a microservices architecture, developers reuse code or duplicate data to increase efficiency and maintain high levels of independence. I believe we already discussed on this, right? Database being common. So probably the scalability and efficiency could be one of the thing, but with microservices architecture, we say that it is more about efficiency and the loose coupling that we want to target. And while working with microservices architecture, though it looks like there would be additional burden which will affect the performance, it's not actually like that. We will be working with small amounts of data only at any time. So that small amount of data actually cuts down on the negative impact of the duplication, right? And it compensates. In SOA, services are made available throughout the enterprise via synchronous protocols. So live calls are there. One service might be calling another service, which might be in turn calling another service. So until and unless the third service doesn't respond, the second will not respond. Until and unless the second doesn't respond, the first will not respond. Mean user is kept on waiting till that time. Whereas with microservices, it's all asynchronous. It could be message brokers, brokered architecture, I mean queues. It could be some eventing system being used like Azure Event Grid or Event Hub service, or it could be some kind of publisher subscriber model also, right? Which is another type of eventing system only. I have published the event, someone has subscribed who gets that event and then takes action on it. So there is no direct communication there. Correct? So here is the tabular version of the same. SOA versus microservices architecture, more summarized. Just have a look at it and see if you have any questions. Yes, any questions? Okay, then let's proceed. Properties and attributes of microservices. From the discussion what we have had so far, we can actually get some pointers here. These all relate to the same. Decentralized governance. Each microservice operates independently. It has its own life cycle. It has its own development team, and it has its own deployment pipeline also. Right? So basically, it's not one common governance module or governance model for the whole application. It's all independently available for each and every microservice. Next point just adds to that: independent deployment. Each microservice is deployed independently. So this enables faster delivery of new features and bug fixes. Right? I don't need not wait for the entire application to be fix for the bugs, and then the deployment is happening. One service had issue, bug fix, deployed. That makes more sense, right? Fine grained services. As the services are small and focused that perform specific functions, by default allows for greater organizational alignment, means the business specific requirements being fulfilled, and the ability to integrate different technologies and programming languages. I hope we discussed this point already. I hope everyone remembers that. Yes. Inter-service communication. So what we have discussed about it, they don't communicate directly. Any communication which is required ideally should be via some broker. Anyhow, if one service needs to interact with the other without the broker also, it has to be based on some standards like REST or gRPC, apart from the message brokers or the brokered architecture. And then data isolation. Each microservice maintains its own data store, so allows better and greater flexibility in data management. For one of the microservice, I may have SQL Server if it is needing 2 or 3 tables to be created for one service only, which are related to each other. If there is no relation, single table scenario is there, I may go for NoSQL storage as well, right? In some specific cases, I may use files also to store the data. So whatever that suits my requirement the best, I will go for it for that service. I need not look at the larger perspective of the whole application. Okay. Important question: what can make a microservices architecture brittle? If you have too many distributed transactions where dependency will be creating challenges, there are multiple direct service interactions going on, that also will create problems, challenges for the microservices architecture. Then neglecting to introduce mechanisms to support fault tolerance, stop or contain failure propagation, establishing the system-wide monitoring and alerting, then automation. So basically the recommendations that we discussed earlier, if you're not adhering to them, definitely the architecture will become brittle. The last point is also important: not designing for test and failure. Right? So any questions so far? Again, I'll wait for a minute. Okay, let's move ahead. Next section is about the containerization systems for microservices. In the beginning also, I said that the containerized microservices or containers are somewhat essential for microservices success. Anybody who would like to speak on this, like why I made this statement, why containers would be important for microservices? Anyone? Anybody who has worked with Dockers or any other container platform probably can speak up. Just unmute yourself and say.
Yeah, one advantage is we can increase the number of instance instantly. Like if
Yes,
required, we can make it 8, 10 as per the user request.
yes. So you're talking about scalability, right?
Yeah, right.
What else?
And another is we don't need a downtime for deploying a fix into microservice.
Yes,
So we can directly create image and directly update the YML. So it's just a
yes.
matter
So
of
I'll just
instance.
add to that. While deployment is going on, probably we can keep the old images running. Meanwhile, the new images are created, and once they are up and running, the load balancer can shift the load to the new services, and the old images then can gradually be shut down once there is zero load on them. Right, Janmeja?
Yeah, yeah, yeah.
So that way the downtime can be avoided. Correct. What else?
Portability.
Portability. Yes, that's right. We can just run the microservice anywhere because the container
Yeah.
can run anywhere, right?
Yes.
There is no system dependency or there is no operating system dependency also,
System.
right?
Yes. Correct.
So technically that means I can run a microservice in my smartphone also, right, Rahul?
Yep. Yes. Yes.
Provided my smartphone should support the containerization platform,
Containerization platform. Yeah.
right? Yeah,
Yep.
that will be one of the requirement. And usually we have that
Yep.
because most of the smartphones these days are Linux based only, and containerization
Yes.
started with Linux only,
Linux only. Yep.
right? So
Yep.
that's correct. What else? Containers are pretty small virtual machines, right? Micro virtual machines. So deployment is pretty easy, pretty quick. In
Yep.
almost seconds, you can just spawn your service and make it up and running. Configuration also takes just few seconds. Correct?
Yes.
And once the configuration is in place, you just deploy it anywhere. There is no problem. It just works. So that's basically something about this slide. Containerized microservices play a very, very important role while setting up microservices. Now, that containerization also brings in something called as infrastructure as a code, right? Because how do you make containers? You write some scripts, right? Docker Compose scripts, which actually contain the instructions for how to set up your container. I mean, the image first of all, and then from image, how the running instance, what we call as container is created, is all set up. Simple YAML script basically can be used to represent your uh, environment, runtime environment. And that's where the term infrastructure as a code comes in. You set up your own machine in a way. As I said, uh, sorry, the containers are basically the micro virtual machines. When I say virtual machine means it is machine. Machine means it is infrastructure. Is that correct? Yes. Now, most important point, what are containers all about? How do they work? I said they are micro virtual machines. What exactly that mean? And what's the problem with virtual machines?
They have their own operating system, so they
Complete
um,
operating system
the
is there, right?
systems. Yes. Yep.
They have complete softwares installed into
Software
them,
system
correct?
installed.
What does that mean? First of all, size is big.
Size is big. Yeah.
So you need
Comput
a very, very high configuration machine to host the VM,
yeah. Computational resources are required.
right?
Yeah.
Then the next thing is because the complete operating system is there, you need license.
Yep. Your cost
Complete
goes up.
softwares are installed, you need complete licenses for them also. Now, size being big, spawning another instance of the virtual machine will take a lot of time. Simply copy paste itself takes a lot of time. They are in GBs, right? 30 GB, 40 GB, 50 GB is the size usually. For enterprise applications, it may be 100, 200 GBs also. Correct? That becomes a challenge. Now, we need the same environment for being portable, but we don't want this big size. So the virtualization went one step ahead. It said that, okay, I will make use of the base machines components only. On the
Yeah.
top of that, a virtual environment I will create, which will have all the things required by my application in addition to what my base machine already has.
Yes.
Kind of a simulator it will build,
Hmm.
which makes it pretty lightweight, hardly few MBs, few hundred MBs, right? Any container you see, the biggest container I have seen till date is 1.2 GB. And now if you go with a typical virtual machine, whichever virtual machine you build, the smallest virtual machine also is somewhere around 10 GB. So the biggest container compared to smallest virtual machine, it is just 10% of the virtual machine, the container, right?
Yep.
Which means a lot. That makes your deployment much more faster,
Faster.
much more
Yeah.
easier. And the scalability also becomes better with this because the size is small. Spawning another instance is not going to take much time, right?
Yeah.
And
Efficiency
the
is the
resource
key part.
utilization also will be better. There will be no
Yeah.
reservation of any virtual machine here, right? Your container, the virtual environment will be running just as another process only, not as a separate machine altogether. So when you are running a virtual machine with 16 GB of RAM configured for it, it will reserve 16 GB for itself, right? Your base operating system will not have the access to that 16 GB of RAM, correct?
Yes. Yes.
Similarly, processor, if you have 8 core processor out of which 4 cores are given to VM, your base machine will have access to only 4 cores. So that's not the case with containers. It is all shared. Just container just runs as a process. So that makes it even more better and faster,
Efficient. Yeah.
more efficient. Okay. So this is what we discussed about, isn't it? Benefits of containers. Reduced overhead, increased portability, faster development, faster deployment, easier adoption for microservices architecture. Basically, this is additional, but that's where we started. And then faster startup than virtual machines. Hardly couple of seconds. Virtual machine is a machine, so complete boot time is required, right? Now, what is Docker? Anybody? I hope everyone has understood containers and their importance. Now, to work with containers, don't you think we need a platform that allows us to create containers, manage containers, and put load into the containers?
Yes.
Docker is such a platform that
Yeah.
allows creating, managing, maintaining the containers along with adding load to them, right? See here, the example which usually I talk about is, I don't know how many of you have
Saket, your
actually faced
voice is
that.
breaking actually. Not sure it's for me.
Is it for all?
No, we can hear you.
Okay, Rahul, probably it might be some network issue at your end.
Yeah, yeah.
Just
I'm in office.
disconnect and
Sure,
connect
sure.
quickly.
Yep.
I'll wait for a minute.
Yeah, I'm back.
Yeah, thanks, Rahul, for confirming. I hope the voice is clear now.
Yeah, it's good.
Yeah, yeah. Okay, so usually I speak about one of the example here. I don't know how many of you have actually faced this situation. I have faced it a lot. I develop some application. I test it on my development machine. It works just fine. I do whatever I can to make it broken, but it just works fine. Ideal situation, isn't it? Guys, just be quick in this.
Yes.
Everything is going fine and as expected. So I am happy as a developer that, okay, I am successful now. Correct? Nightmare starts now. When I hand it over to my QA team, they say the application crashes when I do this thing, one specific task. As a developer, that's a nightmare for me because I tested everything, everyone worked, everything worked without failure. Anybody who would like to throw some light on what could be the reason why this crash is happening?
Environment.
What do you
So
mean by environment, Rahul, in this
some
case?
DL missing or something.
Uh,
Third
Dependency.
third party component.
Yeah, so that's important. He said some DLL missing or might be something like that. So there is no certain answer to this. Am I right? Anuj,
yep.
Rahul, it could be
Yeah,
DLL missing. It
yeah, a
could be
lot
some
of.
other dependency missing. It could be
Mm,
some framework related issue, runtime related issue. It could be
Hmm.
some hardware issue. It could be OS issue.
mhm.
It could be registry issue.
Yeah.
There are so many could be's, isn't it?
Yes. Yes. Yes.
How much time do you think will it take to find out what is the actual issue? Because we don't have any clue here. It's all hit and trial, isn't it?
Yeah.
So whenever we are in a situation where we are doing hit and trial, it takes a lot of time, and it we cannot be certain that okay, I will need 10 hours or 10 days or 10 weeks or 10 months. Am I right?
Yep.
It can be anything. No certainty. There could be a situation where we may not be able to find the issue also. When I put it on some other machine, it just works. So probably the solution is okay, use it there. Am I right? Now, to avoid this issue, what can I do? It all started with VMs only. See, I remember those days, my earlier days, when I used to develop applications using VB5, VB6. This was the scenario quite often. Okay. So I used to carry my entire box with me for the demo at the client place or ask the QA people to do the QA on it. Complete machine, physical machine. Because that point in time, late 90s and early 2000s, basically we didn't have any virtualization at all. Okay, so that point in time, I had a challenge. So I used to carry my box. I had a desktop, no laptop was there. And I was working as a freelancer only. So that was the solution I had. Do you think it is actually feasible? Definitely not. So virtual machines probably gave some solution. Okay, whenever I start developing the application, I will create my environment, I'll develop application there itself, I'll test my application there itself. Now, at the most, what I need to carry is the image of that virtual machine. Am I right? Anybody?
Yes.
Okay, that's easy. But then copying that virtual machine on my user's machine or maybe the QA person's machine will take time. Half an hour, maybe an hour, depending on the size of the VM. Correct?
Yep.
What if I don't have that much of time? It's wastage, right? That's where again container can help me. Docker is a software platform which allows me to create these micro virtual machines, manage them, maintain them, and then do the deployment of the workload also in them. What skill it requires is similar to the skill that I require to create, build, manage my own applications, because it is easily manageable with some code only. That's where we use the term infrastructure as a code. Correct? And when I say that it's a VM only, a kind of a VM only, if that container is behaving perfectly in my machine, wherever it goes, it will just work perfectly because I'm giving whatever is required for my application along with it. I'm not just deploying my application code, I'm deploying the complete environment, which hides the underlying uh, deficiencies, right? So I hope the container concept and what is Docker both are clear.
Yes, Sanket.
Yeah, so that will be actually the end of this session. If you have any queries, I'll just wait for the same. You can unmute yourself, you can put in chat.
Saket, I have just one question.
Yeah,
So what is the difference between Kubernetes and Docker generally?
yeah, I was
I
waiting
need.
for that, Rahul. In fact, I appreciate you asked. Uh, Docker is about creating, managing, maintaining one container image and instance.
Okay.
Kubernetes is more about, the orchestration tool being there for managing the containers.
Okay. Okay. Okay.
Now, when I say orchestration, it is all about automation. It is
Scheduling.
also about something which allows me to do the automation on scalability,
Okay.
right? So uh, you can compare it just like what is Visual Studio and what is Azure DevOps. Visual Studio allows me to build applications, right? Develop applications.
Correct. Yeah.
But when I go for DevOps, it allows me to have a common code repository which combines code from different developers in the team, allows me to automate the builds, allows me to automate the deployments as well. So it is
Got it.
more of an orchestration tool, right?
Yep.
Same is the relation between Docker and Kubernetes. Got it,
Okay.
Rahul?
Thank you. Thank you very much, Saket. Yeah. Got it.
Yeah. Yeah. Next question. Yes, anybody? Okay, I'm putting down my email ID as well in the chat. If you have any further questions, you can always reach me there. Meanwhile, if you still have any questions right now to be asked, I'm there. Just check it out. I've put my email ID also. If no further questions, we'll go towards the end of the session. Thanks for attending the session, and I hope everyone has liked it. Over to you, Payal, if you're there. Payal or Shika.
Yes, Saket sir. Yeah,
Yeah, you
yeah.
can take it ahead towards the feedback and all.
Yeah. Saket sir, thank you. It was a very informative session. Okay, so I'll be putting
Thanks.
the feedback link. I request everyone to please fill the feedback link. I have shared the feedback link. It is a request to please fill it.
We can drop out, right?
Yes, you can. If you have filled the feedback form,
Yes,
uh,
thank you.
yeah, thank you.
Sure, sure. Yeah.
Thank you. Bye.
Bye bye. Thank you.